So, my name is Michael Hausenblas. I am developer advocate at Mesosphere. Before that, I was at MapR. I was chief data engineer at MapR, a Hadoop company. And when I thought about what is it that I can share with people that might be useful, I thought about some experience I had back then at MapR and still have at Mesosphere when, being on site, helping people to benefit from big data. And so I came up with scaling data engineering, since that is something I have a bit of experience on. So let's look at the motivation. What is it that why are we doing these things? Why does it make sense to look at big and fast data? Have you got an idea how much data an average plane produces in one leg? Like, we're talking about terabytes of data. And that's just volume, that's fine. But if I can tell you, or if you know that if you can better estimate when a plane lands, you can get 1 billion per year. That's one airline. You have an incentive, right? You go like, okay, maybe we want to do something with that data. Logistics, healthcare, everywhere, traders, obviously. They typically have some deep pockets. Farmers, trying to optimize where exactly and how to deal with the plants. Smart or not so smart cities. One of the smartest cities I'm aware of is actually in Spain, I believe, Santander, something like that. And last but not least, you, right? I'm wearing this smartwatch, and increasingly so these devices will pop up everywhere, and we will have these body area networks. So it's really data everywhere, data being produced everywhere, and increasingly we're getting an idea of how we actually benefit from that data if we do something beyond just selling better ads. So that's not what I mean. So let's talk about a few trends, some opportunities, and also challenges. Hope you had time to read that, Dilbert. I love it. Camping opportunity, yeah. All right. As I mentioned earlier on the panel, very often when people start building a data lake, they end up with something like that. Although that's a pretty nice picture, actually, but what I mean is a data swamp. The metadata is missing. Everyone is throwing in. It's very, very easy to ingest stuff, but can I actually find data? Can I actually do something with it? So what we really want are not only insights, but actionable insights. We want to do something with that data, when it happens, where it happens, right now. So this kind of challenge, not creating a data swamp, is certainly there. There's an impedance mismatch between what is going on in development and what is in production. And we had that on the panel again. And I've seen that a couple of times, the data scientists write wonderful stuff in R, and it's like, I found it, and then throw it over the wall. It's like, all right, we have Spark in production or whatever, so how do I actually take that wonderful model and scale it and deploy it and operate it? El mentioned it, and I 100% agree. There is a trend towards a 100% self-service, right? And again, as long as you don't put chorizo into paella, you're good. You can pick whatever you have here. The point being, and you see it everywhere, not only core IT. If you can successfully outsource these services and enable people, give them something in their hands to find the data themselves, to use the data, think of Zeppelin, for example, or Spark Notebook or whatever. You only need to provide the infrastructure and enable the people, give them the tools, and they mix and match and whatever they need. So it's very, very fast. You don't have any bottleneck. You don't need to go to someone and say, hey, can you add this data or can you change that schema? It's up to you. You have all the tools. And that's great, right? That's a great thing. And then there is, of course, the cyber, right, or cloud, also known as cloud. Containers and DevOps movement. So this is happening, right? these are things where people increasingly put data in the cloud. And while, data gravity is a thing, if you have a strategy, if you're aware of that, you can do that. And then there are really awesome tools, for example, BigQuery, I'm a big fan of that, that allow you to go through a huge amount of data in like no time. And pretty much, I picked Microsoft here, but pretty much every cloud provider nowadays also has a pretty complete set of offerings around fast and big data, right? You can do stream processing and so on and so forth. And increasingly, you see open source in both directions, either open source offerings being available in the cloud or the cloud providers open sourcing their stuff. And again, that's great. And another thing in that domain, DevOps, so if you only read one book this year, make it this book, Phoenix Project, essentially the DevOps Bible. It really makes the point and explains what the problem is and how to go about that. And last but not least, the new hype around containers. Shown here is the OCI, so that's kind of Docker tomorrow. And it's a young space, and then there are many players, and then still growing. But this is the kind of setting you're increasingly dealing with, right? You have, like, what does DevOps or AppOps actually mean in the context of big data? And already mentioned a couple of times, it's not only big data, it's obviously also fast data. So we've been doing batch processing for quite a while. Increasingly, you want to be able to process the data as it comes in and get to actionable insights. And there is really this entire spectrum. There is not black and white. You have to deal with that entire spectrum, and there are tons of tools. We're going to talk about some of them in greater detail. But you got to be aware of what's the characteristic of the data, anything from data temperature over how is it structured. There's always a structure. It's just a question how explicit it is. So what is the right tool, because there are so many for your use case to get most out of it. There are a couple of challenges. No fancy pictures, just words. Number one, setting up and operating any of those wonderful tools can be quite a challenge. So if you have a data pipeline and you ask yourself, how much time do you spend setting that data pipeline up and operating it at scale, making it reliable and so on, that is a big part. You always have to be able to potentially be able to deal with the back pressure. Something comes up, it's Black Friday or whatever, something happens and your ingestion rate explodes. So elasticity is really key, and one answer to it is the cloud. In the context on the project I'm working on, DCOS, we have this concept of static versus dynamic partitioning, where essentially say you don't reserve certain machines for a certain role. You're leaving that decision up to some scheduler that, depending on the traffic, depending on the needs, allocates certain parts of the resources of compute and storage to the framework or to the component that it needs at the point in time. Obviously, if you're on premises, you're limited by whatever boxes you have standing around, and then there the cloud obviously has a huge advantage as well. And last but not least, for many people, it's also about utilization. So it's really about, can I efficiently use the resources I have at hand? That might be, if you're on premises, you look at 15% or 20% overall utilization. You want to get up to 80%, for example. Or you might be in the cloud and say, like, well, at the current point in time, I don't really need 100 nodes. I can scale back to 10 nodes for the time being. So here are a number of challenges, and I'm trying to suggest how we can go about that. Let's have a quick look at the tooling, just to give you a bit of a feeling, like you have typically a lot of options. So it's not always easy to actually figure what is the right, or what is the right combination of tools to use. One thing you increasingly need are any sorts of message queues and routers. Things like Kafka obviously is there, any kind of in-memory queues, Rabbit or CRM queue or whatever. FluentD, Logstash, Flume, and so on, Akka streams, and obviously you also have like cloud-only native solutions there. But at some point in time, I'm pretty sure you will end up in a place where you need one of those being part of your data pipeline. And there's also a very nice advocacy site, queues.io, that gives you a bit of an overview on the available toolings in that space. Then you obviously have the stream processing platforms, good old Storm, which is now replaced or being replaced by Heron, Apache Spark, Samza, and Flink. There are others like Concord, specifically Mesos-based. And again, you have offerings in the cloud that allow you to do that. They typically work together with these message queues in some shape and form. Some of them are more tightly integrated. Some of them, it's typically a bit more work to get them working nicely together. And then there are time series data stores or databases that, depending on where you look, have a richer API, for example. Influx has a very, very great way to query the data there. Essentially, it's like SQL with a temporal component. You have OpenTSDB and the Cassandra port of OpenTSDB, KairosDB on top of Cassandra. OpenTSDB is on top of HBase. You've got Prometheus, more from the container world, that essentially is an open source rewrite of the Borgmon of the Google internal monitoring tool. So you have a lot of options there as well that allow you to take the data, treat it as a time series, and then do whatever, query it, plot it, or whatever. And we're going to have a look at the demo, how to do that in a very simple case. One point I'm trying to make here is that it is probably now the time that we need a new kind of operating system. And probably you know where the whole thing is going, but I'm nevertheless trying to start at the basics here. In the good old days, right, we had a single application on a single machine. It could be on a laptop or a mobile phone or whatever, the hardware, and we would outsource all the hard bits to the operating system, right? Unless you have a very specific kind of application, like a database, whatever, you don't deal with files, right? That's the file system, that's a service provided by the operating system. You don't deal with threads or memory management or whatever. That is the task of the operating system, and there are syscalls, there is an API that you just use, and you can focus on the business logic. You focus on the application level rather than managing hardware and providing these services. The longest time we have been, interestingly, in the distributed setup, we've been using a slightly different model. We would deal with all the stuff on the application layer, right? So we would have like a node, a couple of nodes here, a cluster with their local operating systems, and then the application layer would take care of everything, right? Network partitions, leader election, whatever you have. Everything would be done in the application layer. So if you look back at that, why don't we have something like this, a distributed operating system that, again, does the same thing that the local operating system does for a single node, just for a bunch of nodes. So the distributed operating system makes a bunch of nodes, a cluster of machines, look like one big machine. I always jokingly say this is mainframes done right, because it's using commodity hardware, very simple to horizontally scale it, and the distributed operating system is taking care of all the heavy lifting, so that you can again focus on the business added value rather than taking care of low-level primitives in a distributed setup. And distributed systems are hard. Believe me that. Just to give you a bit of an idea, if you take, comparing a local operating system, I'm using that term without defining it, with the distributed operating system, if you take the case of DCOS, so you would have something like the Linux kernel, if you talking about Linux-based systems. And then you have a couple of distributions that use the Linux kernel. You, as a user, you do not interact with the Linux kernel as such, right? Unless you're doing a syscall yourself. But you typically, you have userland tools. You have the shell, and you have this and that. That is what you're really interacting with. In the same way, in our case, we're using Apache Mesos as the distributed kernel of this operating system, and DCOS being essentially a Mesos distribution, so taking all the bits, glue code, userland programs, and making it easy for people to use and set up. And just one slide so that you have an idea what it looks like how is DCOS set up. So you essentially have the distributed kernel space, which is made up of Mesos essentially, and then you have the user space where you have system components. These are around 40 different little tools, so it could be DNS or whatever, that are supervised through systemd, and then on top of that, what traditionally was called a framework that has the notion of a distributed process, and that process has different names, right? If you look at Marathon, for example, this process is called an app, and if you look at Chronos, this process is called a job, and in Sparkland, it's also called a job. So how a particular process is called is dependent on the service or the framework offering that, but it is a distributed process. And in the same way that on a single machine, like on your laptop, you don't get asked by the operating system on which CPU do you want to run this application. In the same way, here, essentially Mesos, the kernel space, takes care of that. It finds a machine and runs that for you, and you're dealing with this high-level abstraction of a distributed process up there. The benefits of DCOS and comparable distributed operating systems are if you're using multiple different services together, that you can use one cluster, one physical cluster in that sense, for a variety of things, stateless stuff, any kind of web servers, application servers, stateful services, databases, and so on, these elastic data processing tooling, and CI/CD. You can also have your CI/CD pipeline there. And because of that dynamic partitioning of your cluster, it reacts on essentially what the workload is, and depending on the needs, make sure that each of the components they're using there, let's say a web server and database, gets the resources it needs. And again, in the case of using multiple of these services, you also see typically utilization going up to 50, 60%, some of our customers reporting 80% and more. One last thing before I'm talking or going to the demo, what about humans? So one concept that is really very, very close to my heart, and I'm trying to establish that, I know it from DevOps world, I'm trying to establish that in the data world, is the concept of an app ops. The term itself was invented by Brian Nils from DigitalOcean, and I'm certainly one of the advocates pushing for that. The idea that the person who writes an application or service is also the person responsible for operating it in production. Now, certain setups like serverless kind of enforce that. In other environments, maybe not so much. And just for clarification, I do not mean that this app ops, this developer that wrote something and then also takes care of that piece in production, is provisioning low-level stuff. That's not the person provisions a DCOS or Kubernetes cluster, or is replacing, in case of on-premises, a faulty hard disk drive. That would still be the infrastructure team. And the infrastructure team, the role there changes, and increasingly so, the infrastructure team, what used to be called the admins and ops folks, increasingly become coaches. They help the app ops to do the right thing, make them aware of security and other things, good and best practices around networking, and so on and so forth. So see and understand the infrastructure team increasingly as a kind of coach for your app ops. And yeah, that's an app ops debugging in production, right? And last but not least, now I really come to the demo in a moment, my pet peeve around human fault tolerance. So UX really matters. If you make it easy for people, and easy in the sense of, you know, it's clear what the thing does. Your UI or your API, developers are also people, I was told. UX really matters, pay attention to that. And also protect people from themselves, right? This is really important. Most of the snafus that you see out there, most of the outages have been, at some point in time, caused by fat fingering. Some human in the loop that, whoops, deleted that production cluster, or whoops, that schema change did not go well. So if we can protect humans from themselves, we increase the fault tolerance, because it's not only about the technical fault tolerance, but also about the human fault tolerance. Finally, demo time. So what I'm going to show you is a very, very simple data pipeline that I started yesterday when I flew in from Frankfurt. So I thought to myself, okay, what can I show that, you know, within a couple of hours of coding actually is doing something. So I'm taking data from GitHub. There's a wonderful API, and there's the public API around events. So whenever in your organization someone commits, pushes, comments on something or whatever, that will show up under this API. So that $org would be your GitHub organization. I'm pulling that. There's a fetcher that I wrote in Go that takes that and puts it into Influx. And then I have Grafana that just pulls out the data last 5 minutes, whatever, and shows it. So this was the goal. Setting it up. And I'm just going to show it to you, and then I'm going to tell you what I had to do to get there. So I prepared the DCOS cluster with some, I don't know, five private agents there. So overall, that's this idea of having your data center, your cluster, looking like one big machine, right? In this case, you have a big machine with 24 shares and 82 gigs of RAM. And I did already, because that's the boring part, I'm going to show you in a moment how much effort it was, the three base services there, so Grafana and InfluxDB, and there are many, many more things in the universe in DCOS that you can just install, data-related, and so on and so forth. So it's essentially one-click install or corresponding the command line. So all I have to do now is, hopefully, if the demo gods are with me, I'm launching this fetcher, and with that I'm going to start essentially the ingestion. And I kept that part so that you get an idea how hard it is to deploy something, an app. This is a Go app. There's no Docker here, whatever. It doesn't really make sense. And if you have Go, that's fine. All the dependencies are there. So that's it. It's running. It's running somewhere in the cluster. I don't even know. I don't care. Right? It's somewhere. So okay, and that host, fine. And since I'm using a logical name, I really don't care where it is running. I'm just referring to it by its logical name. So going in here, SSHing into the cluster, because I have deployed it, or I set up the fetcher in a way that this service is only available within the cluster. So the logical name of this application I just launched, of this distributed application, is fetcher.marathon L for LB, which is the level 4 load balancer, this DCOS directory. I exposed it on port 80, and when I hit the start endpoint, then the ingestion should start. So let's have a look at that and prepare ourselves for that. So we should, as soon as I hit that endpoint, we should see something going on if everything goes right. Okay, it's there. That's fine. And now we hit the endpoint. And nothing happens. That's great. Oh, no, there you go. Okay, so you see it says, okay, starting to fetch from the default organization DCOS. Got the events, trying to ingest that into Influx, just some debug messages there to see what's going on. So now the ingestion is going on. Now I'm pulling data, I'm fetching data from the GitHub API and pumping it into Influx. And if everything goes right, I'm just trying to make sure lasts, every 10 seconds, lasts 15 minutes, let's say. Did I say apply? No. Apply. 15 minutes. How about 5 minutes? come on guys, do something, work. Yeah, so San Francisco has not woken up yet. I don't know. So, we give it a few minutes and someone will do something. Yeah, come on, whoever you are, commit. So you see there are two repositories you see there, DCOS, so the core bits and the UI, where hopefully I could use a different one, right? I could take another, hopefully more, what could be, I don't know, the website? Well, I don't know, we have to give it a few minutes. I cannot control that. I cannot command people to push or to comment on stuff. So let's see how it goes, if there is something going on. It should look like that. So if some activity is there, it would look like Grafana.net. I've shared this dashboard on Grafana, so it should be somewhere there. Yeah. So that's the screenshot I took yesterday. So you see, at that time people were actually working. They actually committed and contributed to DCOS, comment on a pull request or whatever it was. So at some point in time we are hoping to see something like that. So you've seen me doing essentially two things: launching this fetcher and starting this fetcher. And really, if you think about that, this is all I had to do. So yesterday, I did DCOS package install, Marathon LB, influx with the configuration, Grafana, and you've seen me live doing the fetcher, the last two things. That's all in terms of operational burden. And this is a production-ready setup. I can take that and use it in production. If you've never set up anything like influx or Kafka or whatever, you probably go like, yeah, whatever. But believe me, before this kind of technology was available, this was really, really and not very thankful and a pretty nasty task to set stuff up and to keep it running. And that is something that, to me, I'm using DCOS here. Other systems, communities, and other systems provide you with comparable things, comparable functionality. But this is really something that is a game changer. That is something that really enables us to move to the next step and benefit from all that big and fast data. So 3 short take-home messages before they throw me out. Try to have short feedback loops. And systems like DCOS enable you to do that. You can quickly do that. Someone can quickly ramp up a Spark cluster, or Zeppelin, or whatever they need, and do their experiments there. Containers and the cloud, the cyber, make the deployment very, very easy. Self-service is it, so leverage that if you can, if your regulations or your CTO or whatever allows it. And again and again, I have to point that out. And whenever I'm at customers, I go like, oh, DCOS, that will solve all of our problems. Like, yeah, I wish it was that simple, but the truth is, any kind of big data technology or DCOS or Kubernetes will not fix your broken culture. Thank you.
Okay, so questions for Michael.
Feel free to hit me up later on outside,
Yep.
coffee break, whatever.
Yeah, fantastic. Thank you very much, Michael.